Today we're practicing working with systems of linear equations. Let's take a look at number 1. Write the equation of each line in slope-intercept form. What is the solution to the system of equations? Okay, let me take a look at my lines here. So first of all, looking at line A, I notice that it's going to have a negative slope because it goes down as we go from left to right. And I see that line B is going to have a positive slope because it goes up as we go from left to right. That's just important to know when I think about reasonableness. And then looking at my y-intercepts, I see that line A has a y-intercept of 2. And line B has a y-intercept of -2. So I know some things about these lines without really even doing a whole lot of work with them. Let me erase what I've written here about the slopes. We know this one's negative. We know this one's positive. Let me take a closer look at these and see if I can figure out the exact slope. I'm going to zoom in a little further. Okay, so looking at line A, let me pick 2 pretty points. I have my y-intercept, and I'm also going to pick this point right here. So I see that as I go 2 to the right, I go down 2. So -2 is going to be my change in y, and +2 is going to be my change in x. Remember that our slope is always our change in y over our change in x. That's the definition. So in this case, my change in y is -2, and my change in x is +2. -2 over +2 is -1. So the slope of that line is -1. And we knew that it would be negative, right? We already found out that it was going down as it went from left to right. Let's look at our other line, line B. I just need another pretty point on this one. I think I'm going to pick this point right here. So on this one, let's see, I'm going to the right 3, and I'm going up 1. So that's +3, and that's +1. So remember, I need my change in y over my change in x. That's going to be 1, +1, over 3, +3. So 1/3. So my slope of this line down here is 1/3, +1/3. We knew it would be positive before we even started. So now I know my slopes, I know my y-intercepts. That's enough to write the equations of these lines. Let's see, so line A, it has, I'm going to write underneath here, it has a slope of -1, and it has a y-intercept of 2. Line B has a slope of 1/3 and a y-intercept of -2. Beautiful. So now let's remember what our formula chart says. It says y equals mx plus b. And it also tells us that m represents the slope. So really it tells us everything we need. All right, so y equals, instead of m, I'm going to write -1. So y equals -1x plus b, which is 2. For line B, I have y equals 1/3 x minus 2. Now, I'll tell you, what we're doing here is harder than what you will have to do on the STAR test. You won't actually have to write these equations for a system of equations on STAR until Algebra 1, but you will need to be able to write the equation of one line at a time on STAR. And so this is good for you to practice doing this here. So good, we're doing it right now. And then let's talk about what the solution is. Just like in our last activity, the solution is just the point of intersection. So it's that point right here that I've indicated in yellow. What is that point? It is 3, -1. And really that's what we're looking for here. That's our answer, 3, -1. The solution to this system. It's the point that's on both of the lines. It's the point that makes both of those equations true. And that's actually why we took the time to write these equations. We want to look at why this is a solution to both of these lines by substituting the solution into each equation. Let's do it. So for line A, let's do that. I'm going to write y equals -1x plus 2. And now, instead of writing x and y, I'm going to write 3 and -1. So for y, I'm going to write -1. And then for x, I'm going to write 3. Okay, and then plus 2. Great. So let's evaluate that and see if it's true. So this is -1 equals -3 plus 2. Yeah, -3 plus 2 is -1. So that's true. Great. All right, now let's check it with the other equation over here. So I have y equals 1/3 x minus 2. Let me substitute my y and my x, and then write in the rest of the equation here, just like that. Great. So now I have -1, and then 1/3 of 1 is just 1. 1 minus 2 is -1. So this says -1 equals -1. So that's also true. So really the whole point in doing this is what we showed is that this point is true for line B and it's true for line A. It's a solution to both of those equations. When I substitute x and y into each of those equations, I end up with a true statement. So that's why that's the solution to a system of equations. Now I want you to know that if you were taking a multiple choice test, you would not need to do all this work. Not all of this would be necessary. The reason why is as if this was a question about system of equations, you would just need to know that that point right there is the solution, and that's 3, -1. That's easy. And if this was a question about writing equations of lines, you could use Desmos to do the work for you, or at least to check your work, right? All you would need to do that is 2 pretty points on each line. So for example, here's a pretty point and another pretty point for line A. So let's see, this is 0, 2, and this is 3, -1. So I could make a table, x1, y1, in Desmos, right? 0, 2, 3, -1. So I would type that into Desmos and I would hit my little regression button, and it would tell me that the equation of that line is y equals -x plus 2. Desmos can do that for you. And then I would use the same process for line B. So I'd pick 2 different pretty points. Actually, I guess I'd pick the same one for 3, -1. I like that point. So here I have 0, -2, and I have, again, 3, -1. So my table here, using the points I used, I'd have x2, y2, because it's a second table. I already have one table. So I'm going to have 0, -2, and 3, -1. And then when I hit this little button on Desmos, what it's going to tell me for this line is y equals 1/3 x minus 2. If you want to, you can pause the video and practice typing that in and trying it out. Then what you'll notice is when you click on the point of intersection, Desmos will even tell you that these are the coordinates of your point of intersection when you click on it. That was a lot to think about, but I think we did a good job with it. Let's look at the next question here. The graph shows the total cost of a pizza at 2 different restaurants based on the number of toppings ordered. Write the equation of each line in slope-intercept form. All right, I'm going to let you pause the video and choose your method of writing these equations. You can look at the graph and find the slope and the y-intercept by hand, or you can use Desmos. So here are my 2 equations, and one thing you have to pay attention to in order to get these is you have to notice that the y-axis is counting by 3s. If you don't notice that, you'll get the slope wrong. All right, so what is the solution to the system of equations? We didn't even need to know those equations to figure it out. It was 312. What does the solution mean in the context of the situation? Talk with your partner about this. Tell your partner, what do you think the solution means in context of the situation? I want you to use a sentence stem. The solution means that. So the solution means that both restaurant A and restaurant B charge $12 for 3 toppings. And then what does the y-intercept represent in context of this situation? Well, think about this. At the y-axis over here, we have 0 toppings on the pizza, right? So that's just the cost of a regular cheese pizza or a pizza with no toppings. Since x represents the number of toppings, the y-intercept is just the cost when you don't have any toppings. All right, let's look at one more question down here. The graph compares the amount of money in 2 bank accounts depending on the number of weeks each person has been depositing their money. What is the solution to the system of equations? Oh, I like this one because it starts out with the easy question. So after 6 weeks, both Layla and Lotus have $250. Great, so 6, 250. Wow, they're saving a lot of money. Okay, circle all of the true statements. It will take 6 weeks in order for Layla and Lotus to have the same amount of money. Yes, that's true. We just said that. After 6 weeks, they both have $250. After 6 weeks, Lotus will have more money than Layla. Well, let's think about that. So Lotus is the blue line here, and after 6 weeks, like at 7 weeks, at 8 weeks, at 9 weeks, at 10 weeks, so at these points, yes, she does have more money than Layla, right? So yes, this is true too. The slope of the line that represents Lotus account is 2/3. So let's see if we can calculate this. We need 2 pretty points. I'm going to choose this one and this one right here. I see that my vertical change here is 100, right? She's gained $100 in this amount of time. And that took her 3 weeks to earn that much money. So it looks like her slope is going to be 100 over 3, not 2 over 3. But do you know where the 2 over 3 came from? It came from not paying attention to the labels on the y-axis, because this is actually an increase of 50, 100, right? It looks like an increase of 2 squares, and it is an increase of 2 squares, but each square represents $50, not $1. So the slope of her line is actually 100 over 3, not 2 over 3. So this one's not true. All right, and then one more here. Layla saves more money per month than Lotus. That statement is essentially saying that the slope of Layla's line is steeper. Let's find out. So just looking at it, it doesn't look like it's as steep. It's the green line right here, but let me pick 2 pretty points and just calculate it. So I'm gonna use, yeah, this looks good. 0, 200, so there's an increase of $50 right here, right? It goes up 50 and it goes over 6. So her slope is 50 over 6. Or we could rewrite that if we wanted to, right? We could simplify it. Let me divide both by 2. And that would be 25 over 3. So Lotus is saving $100 every 3 months, and Layla is only saving $25 every 3 months. So just like we expected, she's actually saving less money per month, not more. So this one is also not true. And we could also just tell that by looking and seeing that Layla's line was not as steep as Lotus's line.